Hello everyone, my topic is all about the illustrate the array implementation of polynomial addition. What is a polynomial? A polynomial p of x is the expression in variable x which is in the form axn plus bxn minus 1 plus up to plus jx plus k, where a, b, c, k fall in the category of real numbers and n is non-negative integer which is called the degree of polynomial. An essential characteristic of the polynomial is that each term in the polynomial expression consists of two parts. One is the coefficient and other is the exponent. Example, 10x2 plus 26x. Here 10 and 26 are coefficients and 2, 1 is its exponential value. It is the pictorial representation of the polynomial definition. The first above, an x raised to n plus an minus 1 x raised to n minus 1 plus up to plus a2 x square plus a1 x plus a0. It is the polynomial expression where a0 and n are numbers. X is the variable. The down below we can see that with an example it depicts the term 3x square minus 5x plus 4. This has three terms: term 1, term 2, term 3. And the variables are x and the coefficient is 3, 5, 4 and the exponent is 2, 1. We can depict which is not a polynomial. N of x is equal to 2x square plus root x. This cannot be a polynomial because x cannot be inside a radical. Then coming to n of x is equal to 3x cube plus 4x raised to minus 2 plus 3. It is not a polynomial because no negative exponents are allowed. N of x is equal to 8x square minus 2 by x. X cannot be in the denominator, so it's not a polynomial. N of x is equal to 4 raised to x plus 3. X cannot be an exponent, so it's not a polynomial. N of x is equal to 5x raised to 1 by 3 plus 3x square minus 2. Exponent cannot be a fraction, so it's not a polynomial. Points to keep in mind while working with polynomials. The sign of each coefficient and exponent is stored within the coefficient and the exponent itself. Additional terms having equal exponent is possible one. The storage allocation for each term in the polynomial must be done in ascending and descending order of their exponent. Representation of polynomial using arrays. There may arise some situation where you need to evaluate many polynomial expressions and perform basic arithmetic operation like addition and subtraction with those numbers. For this, you will have to get a way to represent those polynomials. The simplest way is to represent a polynomial with a degree n and store the coefficient of n plus 1 terms of the polynomial in the array. So every array element will consist of two values. One is already mentioned above like that, coefficient, and the second is exponent. Polynomial representation in array. First method. One-dimensional array is defined and coefficient is added to the array and exponent is indicated by the index value. This picture depicts the polynomial expression of the first method. P of x is equal to 5x raised to 21 plus 3x raised to 15 plus 8x square plus 5, and the q of x is equal to 4x cube plus 2x square plus 91x plus 10. And the polynomial expressions are enlisted in the arrays is depicted down below. And the second method is, here we use a single dimension array to represent the polynomial, but we store both the index and coefficient in a single array itself. The example is b1 of x is equal to 23x raised to 9 plus 18x raised to 7 plus 41x raised to 6 plus 163x raised to 4 plus 3. We are depicted in the array format. In here, the 5 represent the number of terms and the 9 represent the exponent and the 18 represent the coefficient. Here 4x raised to 6 plus 10x raised to 4 plus 12x plus 8, and the array representation for this polynomial expression is depicted below. The next method is third method. It's using structures. Here we have two expressions and their coefficient and exponent are separated below in the two tables. And the third method with the structures also with the pointers. This is the simplest polynomial representation. If the polynomial is minus 10 plus 3x plus 5x square, then we can write it as minus 10x raised to 0 plus 3x raised to 1 plus 5x square. This is the simplest and basic polynomial representation. Polynomial representation. A polynomial of a single variable a of x can be written as a0 plus a1x plus a2x square plus up to a raised to n x raised to n, where an not equal to 0 and degree of a of x is equal to n. For the polynomial addition, we are using an algorithm. That algorithm are depicted here. Procedure PADD ABC, and it starts like that. And the algorithm that are implemented here to solve this problem. After solving all this with this algorithm, and we get the correct required expression for that polynomial. Thank you.